have 4 resistors like this, P, Q, R, S, and there is a resistor which is connecting these 2 points. This is a Wheatstone bridge. When we talk the Wheatstone bridge, one is Wheatstone bridge, the other is balanced Wheatstone bridge. When the Wheatstone bridge is balanced, it means the current in this arm, that is going to be equal to 0, that is the ammeter reading should be equal to 0. And that happens when the resistance of P by Q is equal to R by S. If P by Q is equal to R by S, then there will not be any flow of current in this arm, that is ammeter reading is 0. When the ammeter reading is 0, though there is some resistance between the points L and M, but still ammeter reading is 0, because this is balanced P by Q is equal to R by S. This means the potential of L and potential of M, that should be same. That is, there should not be any potential difference, because for the flow of current in the resistor we need some potential difference. And if you see there is no current flowing in this resistor, it means the potential difference across its ends, that should be equal to 0. That is, both the points, they should be at the same potential. If P by Q is equal to R by S, then I is equal to 0. When I is equal to 0, it means VL, potential of this and potential of this, that should be same. Suppose we have to prove it. So what we can do is, we can go in the reverse manner also. We say, that is, if VL is equal to VM, then it should be, that is, P by Q should be equal to R by S. That's one and same thing. If VL is equal to VM, then P by Q is equal to R by S. Now the current I1 is flowing through this, I2 is flowing through this, and we are saying this and this, they are same potential, so that there is no current which is flowing through this. And now we have to prove that P by Q is equal to R by S. This should be met. Only then VL, potential of L and potential of M is going to be same. Now let's say the current I1 is flowing through this arm, current I2 is flowing through this arm. As a result, the potential drop across this is going to be I1 into P. That is the potential drop across this, and across this it is going to be I2 into Q. This is at one potential. Suppose this is this is at one potential. The drop across this should be equal to drop across this. Only then obviously the potential of L and potential of M should be same. So potential of L, we can say, if this is at V potential, so it is going to be V minus I1P, and V M should be equal to V absolute potential V. Suppose we are taking the absolute potential of this point A as V. Difference is, drop is I2Q, so it is I2Q. We have used Ohm's law only. V is equal to IR only, we have used it. Drop is this much, current is flowing, conventional current is flowing in this direction, so that's why potential of this is greater than potential of this. Similarly, the electric potential of this is greater than electric potential of this, because the conventional current is flowing in this direction. We know the conventional current flows from a higher electric potential to lower electric potential. So the potential difference is I1P. This is the potential of A, we have assumed that V. Drop is this much, so the remaining potential of this is VL is V minus I1P, and Vm is V minus the drop, the difference, that is I2Q. If we say VL is equal to Vm, this means that is V minus I1 into P should be equal to V minus I2 into Q. So this implies I1 by I2 is equal to Q by B. Similarly, if you look over here, the drop across this is going to be, that is I1 into R, and the drop across this is going to be I2 into S. The total drop, the total difference across this or across this is V only. For the ease of understanding, let's say the potential difference between A and B is 100 volt. If 30 volt is a drop across this, so remaining should be 70 volt across this. Similarly, if 30 volt is across this, the 30 volt should be across this. That is what we mean over here. Then only VL and VM should be same. So 30 volt is suppose potential drop across this, the remaining 70 should be across this. So I1 into P is a drop across this, I1 into R is drop across this. So this drop is equal to this drop, and this drop should be equal to this drop. That is I1 into R should be equal to I2 into S. So over here this means I1 by I2 is equal to S by R. I1 I2 is Q by P. So this means Q by P is equal to S by R, or let's say we can rearrange it. We can either say this or we can reverse it. So it means P by, so this means P by Q is equal to R by S. We have proved it. So one is Wheatstone bridge. When we talk the Wheatstone bridge, then certainly this is a kind of a Wheatstone bridge where we have 5 arms, 1, 2, 3, 4, 5 resistors, they are joined like this. When we say it is balanced Wheatstone bridge, then there will not be any current flowing in this wire. So whether you put the resistance over here or you remove it, that doesn't matter. So the condition for the balanced Wheatstone bridge is P by Q is equal to R by S.